For as long as humanity has existed, we have looked up at the night sky with wonder and questions. Ancient civilizations mapped constellations, told stories of gods and monsters, and used the stars to navigate oceans and deserts. But beneath that beauty lies a far deeper mystery, one that the James Webb Space Telescope, humanity's most advanced eye in the sky, is only just beginning to unravel. From its position a million miles from Earth, shielded from the sun by a massive heat shield, Webb peers into the infrared universe, seeing light so ancient it has travelled for over 13 billion years to reach us. This is not just astronomy, this is time travel, and the journey Webb has taken us on is one that has both inspired awe and shaken the foundations of everything we thought we knew. But to understand why these discoveries have scientists rethinking the very origins of the universe, we need to start with what Webb was built to do, and what it has already done that no one expected. When Webb launched in December 2021, the scientific goals were ambitious, but clear. Look farther back in time than any telescope before, study the formation of the first galaxies, and probe the atmospheres of distant planets for signs of life. Its segmented gold-coated mirror, spanning 6.5 meters, collects faint whispers of infrared light that other telescopes can't detect. Combined with its location at the second Lagrange point, Webb can observe without interference from Earth's heat or light. But from the very first deep field images, those now famous mosaics of thousands of galaxies, astronomers noticed something unexpected. Some galaxies looked wrong. Not in the sense of a photographic glitch, but in what they represented. Fully formed, massive galaxies appearing far earlier in the universe's history than theory allowed. This was the first crack in the foundation, and it would not be the last. Standard cosmology tells us that after the Big Bang, the universe was a hot, dense soup of particles. It took hundreds of millions of years for the first stars to form, and hundreds more for those stars to gather into large galaxies. Yet Webb's data revealed galaxies that were already enormous, as big as our Milky Way, just 300 million years after the Big Bang. That's like finding a fully grown forest only weeks after seeds were planted. These galaxies are not only massive, but also structured, with spiral arms and central bulges. According to our models, they simply shouldn't have had time to grow and organize themselves this way. The implication? Either our understanding of galaxy formation is wrong, or the universe had a head start. And if it had a head start, what does that mean for the Big Bang itself? Webb's discoveries weren't limited to galaxies. In its exoplanet studies, Webb examined CHIP6 5426b, a planet several times more massive than Jupiter, orbiting far from its host star. Traditional models suggest giant planets form close to the leftover material in a protoplanetary disk. But this planet orbits so far away that its existence challenges the very physics of planet formation. Even more puzzling, the system itself is relatively young, meaning there shouldn't have been enough time for such a massive planet to form naturally at that distance. The theories began to shift. Was it thrown outwards by gravitational interactions? Or could it be a captured object from another star system entirely? If so, it's a cosmic wanderer. One of the most beautiful phenomena Webb has captured is an Einstein ring. The bending of light from a distant galaxy perfectly around a closer one, creating a circle of light. While gravitational lensing is well understood, one particular ring Webb imaged is so perfectly symmetrical that it has raised eyebrows. The alignment required is incredibly precise, to the point where some have suggested we might be seeing hints of an underlying structure to space-time itself. If the fabric of the universe has hidden symmetries, what could that tell us about its origin? And more importantly, about its designer, if there is one. Webb has also contributed to our study of dark matter, the invisible substance that makes up about 27% of the universe's mass. In one observation, Webb detected gravitational lensing effects in an area of space where no visible mass exists. The distortion was stronger and more defined than expected for diffuse dark matter. It behaved like a concentrated object, something with structure and boundaries. Could this be a dense clump of dark matter? Or is it something else entirely? Perhaps an ancient, invisible relic from a time before stars and galaxies. The large-scale structure of the universe, the cosmic web, is a network of galaxies and dark matter forming filaments and voids across billions of light years. Webb's high-resolution mapping has revealed a filament over 1 billion light years long, with a startling regularity. Galaxies along this filament seem evenly spaced, and the voids between them are nearly uniform. While gravity alone can create large-scale structure, the level of symmetry here is unusual. Some researchers wonder if this is simply chance, or the faint fingerprint of something more deliberate. One of Webb's primary missions is to study exoplanet atmospheres. Using spectroscopy, Webb has detected water vapor, carbon dioxide, methane, and other molecules in distant worlds. In some cases, the ratios of these gases hint at processes we don't fully understand. Possibly geological, possibly biological. We're not talking about alien civilizations, but if life exists elsewhere, its first detectable sign might be hidden in these chemical fingerprints. And Webb is the best tool we've ever had for finding them. Another puzzle. Some of the earliest galaxies Webb sees are far brighter than expected. This could mean they contain many more stars than models predict, or that the stars themselves are different, possibly larger and hotter. The so-called population 3 stars, thought to be the universe's first generation. If Webb is indeed spotting these ancient giants, it's witnessing the very first chapters of cosmic history. Chapters we didn't even know existed. With each new discovery, astronomers are faced with a choice. Tweak our existing theories to fit the data, or consider that some of our fundamental assumptions about the universe are incomplete or wrong. This is not the first time in science history that a new instrument has forced a revolution in thinking, but the scale here is staggering. The Big Bang model, dark matter, dark energy, galaxy formation, all may need to be rewritten. As of now, Webb has given us more questions than answers. How could massive galaxies form so early? Why are some exoplanets breaking all formation rules? What are these dark matter-like structures with defined shapes? Is the cosmic web's symmetry just coincidence? Are we seeing the first stars, or something else entirely? The James Webb Space Telescope was built to reveal the universe's past. Instead, it may have given us a glimpse of something deeper, a reality where our current understanding is just the beginning. Whether it's rewriting the timeline of cosmic history, challenging the laws of physics, or hinting at hidden structures in the fabric of space itself, Webb's work has only just begun. And perhaps the most thrilling and unsettling truth is this: every answer it gives us will lead to more questions. Because the universe isn't just stranger than we imagine, it's stranger than we can imagine.